Hello students, in the last session we completed sums that were related to kinematic equation and we did solve sums that were related to graphs and those kind of sums, right? So in this session we will do sums that are related to kinematic equation, those leftover sums, and we will do like relative velocity sums, right? So you get around like 3-4 questions that are related to relative velocity. Majority of the sums that are related to relative velocity, we will see those sums in the next chapter, which is like motion in a plane, okay? So because relative velocity sums always comes when you have like two-dimensional motion and things of that sort, okay? Therefore we will do those sums, majority of the relative motion sums in the next chapter, which means in motion in a plane. As if now you got like 3-4 sums that are related to relative velocity, which we will do in this chapter, okay? So the last part will be like 21, 22, 23, okay? So these last 3 years PYQ will also be done in this session, right? So altogether we'll get around 13 to 14 sums that we will do in this session, right? So let's jump into it. Let's see what's the first sum is. 21st sum, which is like a particle moves in a straight line with a constant acceleration, right? Okay, so a particle is moving with a constant acceleration, which means I'll be able to use kinematic equation. It changes its velocity from 10 meter per second to 20 meter per second. Okay, they have given the initial velocity and then the final velocity is done. While passing through a distance of 135 meters, the value of t is what I'm supposed to find here is the time t, right? So they have given me the distance and they're asking me to find the time, right? So the equation that I should use is like s equals ut plus half at square. That's the equation from which I'll be able to get the time, right? Okay, so I'll use the second equation, which is like s equals ut plus half at square, right? Let's see what are all the parameters that they have given in the question. You got like 135 meter, distance is known, then initial velocity u is known, time t is something that I need to find, okay? Half a, acceleration is not known, same way t square is something that too is not known, which is something that I need to find, right? So what are the other data that is given over there is you have like initial and then the final velocity, right? So these two velocities are given, which means when you have initial final velocity and then I'll have to relate it with respect to time, right? Therefore let me try the first equation, which will be like v equals u plus at, right? I'll write this equation. So in this equation, if I substitute the data that are in the question, you will have 20, which is equal to 10 plus 80, right? Yeah. So if I do the rearrangement thing, I'll have 80, which is equal to 10. Got it? So now I have got 80, right? Let me verify if I'm able to substitute that one in this equation. So if I need to substitute that one here, obviously, so I'll be able to write this one as 80 into t. Instead of 80, I'll be able to substitute 10. Okay, then you'll have like 1t and the one term, and the other term you have like 1t left, which means I'll be able to factor out t from this parameter. Rest all other things are known. Therefore, if I solve, I'll get the time here, right? So these are simple sums. Let me do the solving thing. So here, instead of u, I'll substitute like 10, and then you have like t plus half. Okay, so instead of 80, I'll be able to substitute 10, right? And then you got like one more t left, which will be like t, right? So here I'm supposed to find the t. Therefore, instead of s, I'll be able to substitute 135. Got it? Just factor out the t from this part. You will have t, and then you'll have 15 inside the bracket. You'll have like 135, right? Let me do the solving. We'll get the answer. So the solving will be like, this is like 3. Got it? So you got like 2, 35 will be like 7, and then if you do it, cancel it out one more time, you'll have 9, right? Therefore t will be equal to 9 seconds, right? That's the answer here. Got it? Right? So these are simple kinematic equation sums. You shouldn't have any doubt in these kind of sums. Let's move to the next one. Next sum is also a simple one. Let's see what it is. The distance traveled by a particle starting from rest and moving with an acceleration of 4 by 3 meter per second square, okay? So you got an acceleration to be like 4 by 3, okay? In the third second is. So what I'm supposed to find is the distance traveled by the particle in the third second. That's what I'm supposed to find here. They have given me the acceleration, right? So distance covered in the nth second. That's a formula that we have seen in the theory itself. I'll use that formula straight away. You'll get S equals U minus half G 2n minus 1, where n equals to the second, right? So here the nth second is actually the third second, fine. So between 2 to 3 seconds, what's the length that it has covered? That's what I'm supposed to find here. So that will be like nth second, right? So here I have already told you in the theory part, I just put the negative sign over here. That's why for G, I'll substitute the positive value, which could be like 9.8 or 10, depending the situation, right? So here, the thing is they have given you the acceleration. This is not the case of ball falling downwards. This is something different, right? So here they have given you the acceleration for a car which is moving with a constant acceleration, which is equal to 4 by 3 meter per second square, right? So in the situation, they have given you the acceleration to be positive. Therefore, I shouldn't consider the equation in this fashion, right? Because this negative sign comes into picture because of the acceleration due to gravity, which is actually acting downwards. That's the reason why I put this negative sign. But that's not the case here. They have told you clearly the acceleration is positive, which is acting on some object, right? It could be car, whatever it is, right? Therefore, let me do some tweaking to this equation. You will end up getting S equals U plus half A to n minus 1, right? I didn't substitute this negative g, right? Instead of this negative g, I just took it as positive. That's what this represents. If I do the solving, I'll get the answer straight away. So instead of n, I'll substitute 3, and instead of a, I'll substitute like 4 by 3. Just do the solving, you'll get the answer, right? It starts from rest, therefore u will be equal to 0. So you will get the answer straight away, which is like s equals half. For a, I will substitute like 4 by 3, right? So for n, I'll substitute 3, which will be like 3 into 2, which is like 6. 6 minus 1 is like 5, right? Okay, let's solve this one. So you have 2 in the numerator, which just multiplies to 10. 10 divided by 3, that's my answer. Therefore, the answer here is option 1. So this is also a simple sum. You shouldn't have doubt in it. Let's move to the next one. Next sum is also a simple one. Let's see. Two bodies, capital A, which has a mass of 1 kg, and then B, which has a mass of 3 kg. So you got like two bodies, okay? They have given you the masses, are dropped from height 16 meters and 25 meters respectively. Okay, the ratio of the time taken by them to reach the ground is, so what is the time taken by those two objects when it is about to reach the ground, right? So we know from the kinematic equation, mass doesn't come into picture, right? So only to confuse, they have given you the masses over here, right? So do not consider the mass, just do the kinematic equation, you'll get the answer, right? So what are the parameters that they have given us? They have given you the height, which means the distance, and what they're asking us to find is like time. So obviously, I will have to use the second kinematic equation, which is like S, which is equal to ut plus half at square. This is what I'm supposed to use, or dropped from heights. Okay, so they haven't given anything that is related to the initial velocity, it's just dropped. Therefore, obviously, initial velocity should be equal to 0, right? So let's use ratio logic and I'll get the answer straight away. For first height, I'll substitute like negative 16 because the object is falling downwards. Even if you don't use negative, you'll end up getting the correct answer. But I'm just sticking to the sign convention, okay? Minus 16 and then half. Instead of g, I'll substitute like negative 10, right? For t square, that's what I'm supposed to find, right? So that's going to be like t square, which is like t1 square for the first case. And then for the second case, you got like negative 25 half and then negative 10 t2 square, right? If you do the solving, you'll get half, it gets cancelled out. Negative 10, it gets cancelled out. And then on the left hand side, we should take the roots, right? So before taking the root, let's solve the sign. So you'll have like plus plus. So if you take the root, you'll end up getting root 16 divided by 25. That's going to be like 4 divided by 5, right? The answer here is option 1, right? These are like simple sums. Let's move on to the next one. Next sum is a ball is thrown vertically upwards. I'm throwing a ball vertically upwards, okay? It has a speed of 10 meter per second when it has reached one half of its maximum height, right? So when it has reached half of its maximum height, so it is about to reach some total height. So when it is at a distance of half of its total height, it has a velocity of 10 meter per second. That's what they have given here. We do not know with what velocity I have thrown the ball upwards. That is not known. The thing that they have given here is the speed of the ball when it is half of its total height. Okay, that's what we know here. Okay, what I'm supposed to find is how high does the ball rise. So I'll have to find that capital H. That's what I need to find, right? So let me draw a diagram so you'll get a clear understanding of what I've told you. So you are throwing up a ball with some velocity u. So this is not known, right? So when it has reached half of its total height, which means when it has reached h by 2, Got it? The velocity was equal to, I'll consider that to be my initial velocity for solving purpose. That will be like 10 meter per second. Got it? So what is the height that is left over? That will be like h by 2 to reach the maximum height, because they have given us clearly this height is half of its total height, right? So the leftover height should be like h by 2, obviously. So the leftover height is like h by 2. That's what it needs to reach. So this height is h by 2. When it has reached that h by 2 height, its velocity will become 0, right? Final velocity will be equal to 0, right? So I'll solve the sum such that this will be like my main portion, right? So I'll apply kinematic equation to this part for the second section. So from that second part, I'll get the value for h by 2, right? So if I get the answer for like h by 2, then just do the cross multiplication, you will get the total height h, right? The only tricky part in this sum is they have given us the second part of the motion, right? So we'll have to consider the velocities of the second part of the motion to get the height, which is like h by 2. Then if I need to get the total height, just do the cross multiplication with 2, you will end up getting the total height, right? Let me do the solving, you'll get it. So here the kinematic equation that I could use will be like third kinematic equation, because we know the relation like v, which is like velocity, and the thing that we know is like height, right? So what I need to find is also height. Therefore choosing the third kinematic equation makes sense, right? So I'll choose the third kinematic equation, which is like v square minus u square, that is equal to 2as. Fine. Let me substitute the values. For v, I'll substitute like 0, right? For the initial velocity, I'm considering the second part, therefore that will be like 10, right? As it is moving upward, that's like positive 10 square. Anyway, we will square it, which is equal to 2, obviously. Then instead of acceleration, I'll substitute like negative 10. Got it? And then for height, for s, I'll substitute like h by 2, right? So here I'm finding the height of the second part. Just do the cross multiplication to get the total height, right? So if I do solve this one, what will I end up getting? I'll have, so the next step will be like negative, negative, it becomes positive 100, which is equal to 20 h by 2, right? So if I do the solving, you'll have zeros, zeros will get cancelled, zeros, zeros, and then this will be like 5, right? So h by 2 is actually equal to 5. Then what should be the h? H should be equal to 10. So h by 2 is 5 meters. Second part height is like 5 meters. Then the total height should be 10 meters. Got it? You should be able to understand this one. The answer here is option 1. Alright. You shouldn't have any doubt in the sum. Let's move on to the next one. Next sum is conceptual based sum, and it is also a little bit tricky. Let's see how to solve it. A man throws a ball with the same speed vertically upwards, which means he is throwing a ball upwards, right? One after other at an interval of 2 seconds, right? So he's throwing the first ball and he takes like 2 seconds to throw the next ball, right? So the interval between the throw of the two balls will be like 2 seconds, right? So you can imagine him to be like a juggler, okay? The circus guy who is throwing the ball one after other and then he is catching on the other hand, right? So that's what it is here, right? So what's the next statement is, what should be the speed of the throw so that more than 2 balls are in the sky at any time, which means in the sky there should be at least like 3 balls. More than 2 balls means you should have like 3 balls in the sky. That's what here they have given in the question, right? More than 2 balls, which means like 3 balls, right? So let's consider a situation when time t was equal to 0, he was throwing a ball upwards, right? So that will be the first throw. So next he will throw the ball when time t was equal to 2 seconds, right? When time was equal to 2 seconds, right? So that will be the next throw. Got it? So in this situation, if you consider, if the time was greater than 2 seconds for a ball to stay on the sky, then it means 2 balls will be on the sky, right? So that will be like equal to 2 balls are in the sky at any time. Then the time should be like t equals 2 seconds. But what they have given here is more than 2 balls, which means 3 balls should stay on the sky, right? Therefore, till t equals 4 seconds, the first ball shouldn't reach me on the other hand. That's what this represents, right? So t was equal to 4 seconds, which means, so here he just threw the first ball, it was on the sky, right? Then he took like 2 seconds and then he threw the second ball, right? In this situation, you got like 2 balls on the sky, right? So if the time was greater than 2 seconds, he should throw, if he threw with such a velocity, then more than 2 balls, 2 balls will be on the sky, right? But the question they have given over here is more than 2 balls should stay on the sky, which means 3 balls should be there, right? So in the 4th second, he will just throw the third ball, right? So when he has thrown the third ball, so now you have like 3 balls on the sky, right? So the time is like, it should be like greater than 4 seconds. That is when you have like 3 balls on the sky, right? So then what could happen is the first ball that I throw can come to my hand, right? So it could stay more than that also in the sky. That's not the problem. But the question here is more than 2 balls should stay on the sky, which means I'll have to take a time. I'll have to consider a time which is like greater than 4 seconds. If I consider like less than 4 seconds, then the first ball could have reached the other hand, right? So then in that situation, like only 2 balls will be on the sky. That shouldn't be the case. Therefore, I'll have to consider greater than 4 seconds, right? So if a ball has to stay on a sky greater than 4 seconds, then with what velocity should I actually throw the ball? That's what I need to find here, right? Okay. So here I just found the first hint, which is like time should be greater than 4 seconds. That is something that is found. What I need to find here is the velocity is something that I need to find here, right? With what speed the throw should be there so that more than 2 balls are in the sky, right? So I'll have to get the speed in this situation. Therefore, if I have to get the speed in this situation, the relation is such that between velocity and then the time, therefore I'll be able to use the first kinematic equation, which is like v equals u plus at. This is the equation that I could use. Here, initial velocity u is something that I need to find, right? So what should be the speed of the throw? U is something that I need to find. So v isn't known, but anyway we will be able to get that. And then acceleration a will be like 9.8. I'll have to substitute 9.8 in this situation because they have given us 9.8, right? And then if you look at the option, it is pretty clear. I should substitute 9.8, right? So it is in multiples of 2, right? Obviously, therefore I'll have to use 9.8. And then for time I will substitute like 4 seconds. Got it? So only thing that is missing over here is like final velocity. To get the final velocity, we will use energy balance concept. Okay, so we are just throwing up with an initial velocity u. Then when it reaches the same point, it will have the direction to be reversed, but you will still have the same velocity into it, which means the magnitude will still be the same. Only thing is number will be same, but the direction will be reversed, right? So if you're throwing it upwards, it will be like positive. When it comes downwards, it will be like negative, right? So the final velocity will be v will be equal to negative of u, right? So this is kind of a new idea that I've given you here, but the thing is you'll get used to this idea in the upcoming chapters, right? So in work, energy and power, laws of motion, we will use this concept again and again, right? So we'll get used to it, but you should know this one. So with whatever speed that I threw it upwards, it just came back with the same speed, but the thing is the signs got reversed, which means the direction got reversed, right? So the final velocity here will be like negative u. That's what you need to know. So now I know the initial velocity, which is like u, the final velocity is like minus u, right? And then the acceleration here is like 9.8, negative 9.8. Only thing that is left is like time. So that's what I'll have to get. So if I do the rearrangement, so let me do the rearrangement here. So you will have v, got it, which is negative u minus u, which is equal to u plus at, right? So if you do the rearrangement stuff, we'll have like minus 2u, which is equal to minus g divided by t, and the time will be equal to 2u divided by g, right? So the time here is like 2u divided by g. Fine. Here we know that time should be greater than 4 seconds, right? So that's the logic that I have argued you before. Therefore, you should know here the t should be greater than 4 seconds. If the t was greater than 4 seconds, then what should be the u? That's what I need to find here. Therefore, this parameter should be greater than 4 seconds, right? So if I do the rearrangement, you'll have 2u, which is greater than 4 into 9.8, right? So 2 will get cancelled. So we'll just be left with 1 2. Got it? So this is like 9.8. So if I do the multiplication, I'll have the u, which will be like greater than 19.6 meter per second. Fine. So if the time is greater than 4 seconds, then the velocity with which I should throw should be greater than 19.6 meter per second. That is when 3 balls will be on the sky at any time, right? So more than 2 balls means it could be like 3 or 4 balls. In order to keep at least 3 balls on the sky, I should throw the first ball with a speed that is greater than 4 seconds. Okay, if it was equal to 4 seconds, then what will happen is when the first ball is about to launch, the second ball would have reached on the other hand, right? So in that particular instant, just only one ball will be on the sky. So that is not possible, right? Therefore, whenever I just throw, it should be greater than 19.6 meter per second, or else the time of the first ball should be greater than 4 seconds, so that I have like 3 balls on the sky, right? So that's the thing that you need to know. Fine, so we'll be able to match it with the option over here. Here the option is like more than 19.6 meter per second. That's my answer. Let's verify other 3 options. The first one is at least 9.8 meter per second. That's not the case. Any speed less than, no, that's not the case. Only with 19.6, that too is not the case, because it should be greater than 19.6. If it was equal to 19.6, even in that situation, the first ball would have reached the ground, would have reached the other hand, where in the case the second ball will be in my hand, right? So in that particular instant, only one ball is on the sky, so that case is not possible, right? Therefore, t should be greater than 4 seconds. In that situation, I'll get the velocity to be greater than 19.6 meter per second, right? So this is little bit tricky sum. Anyway, you should understand the concept and logic behind it, right? You shouldn't have any doubt in this sum. Let's move on to the next one. Next sum is also a little bit tricky. Let's see how to solve it. If a ball is thrown vertically upwards with a speed u, right? So the initial velocity is like u, the distance covered by the ball in the last t seconds of its ascent, okay? So what they're asking us to find is like last t seconds, right? First t seconds is obviously easy, right? S equals ut plus half at square, right? So that will give me the distance covered in the first t seconds. Now what I'm supposed to find is the distance covered in the last t seconds, right? So let me draw a diagram. You'll get a clear understanding of it. I'm throwing a ball, right, upwards with some velocity u. The speed will be like initial velocity is like u, and then what I'm supposed to find is the distance covered in the last t seconds. Got it? So let's make it this way. For the complete motion, it will take around capital T. So that's my time, and the total distance h will be like capital H. Okay, so if they're asking us to find the distance covered in the first t seconds, then it's like obvious, right? H will be equal to ut plus half at square. So that will give me the distance covered in the first t seconds. What I'm supposed to find here is the distance covered in the last t seconds of its ascent, which means before reaching the velocity 0, what will be the height that it has reached, such that I'll have to count from the top. Okay, from the ascent I'll have to take the time, which means, for example, the time of ascent could be like 10 seconds, right? So when the time was equal to 10 seconds, the ball would have reached the maximum highest point, right? Then it will change its direction of motion. Fine. So what I'm supposed to find here is not like the first 2 seconds. What was the distance covered? That is not what they're asking us to find. They're actually asking us to find at the last 2 seconds, which means from 8 to 10. From 8 to 10, in that interval, what was the distance that it got covered? That's what I'm supposed to find here. Therefore, I'll put the t for the last ascent, right? So here, let us put it this way. Total height was like h, and the total time taken to reach the maximum height was like capital T. Got it? Let's split it into 2 parts. Let me take the last part to be like small t seconds. Okay, so in order to reach this section, it took like small t seconds. Fine. So with that, it reached its maximum height. Fine. So what should be there? Before time should be like capital T minus small t, right? Which means here, let me take the total ascent time duration to be like 10 seconds. Now I need to get the answer for like last two seconds, which means 8 to 10. What would be the time for the other part of the ascent? It will be like equal to 8 seconds, right? So that part is capital T minus small t here, right? So for the leftover part, you will have the time to be like capital T minus small t, right? So now I drew the diagram for it. Now I can solve it, right? So in order to get this h, this is like h. I'll give notation for it also. So in order to get this height, which means last t seconds, what I should do is I'll have to subtract the total height from the initial part of the height, right? So the initial part of the height could be considered like h dash. Okay, so here I'm just giving variable to all those things. Fine. So if I only give variables in this pattern, I'll be able to get the distance covered in the last t seconds, right? You shouldn't have any doubt in this sum. Now I'll just input all those data that I've given here into this formula, s equals ut plus half at square. Okay, to input that kinematic equation, first I will form an equation for small h. Therefore the small height, which means the last t second height, will be equal to total height capital H minus h dash, initial leftover height, right? So capital H minus small h dash will give me the small h, which is something that they are asking us to find, right? So to get the capital H, the thing that I'm about to substitute here is ut plus half at square, right? Initial was like, initial velocity was like u, and then the total time to reach its maximum height was like capital T minus half, right? For g, I'll put the negative, therefore I multiplied it in the front itself, minus half g capital T square, right? So ut minus half gt square, that gives me the capital H. Then the h dash will be capital T minus small t, right? So for the second part, negative of u capital T minus small t minus half g capital T minus small t the whole square, right? Now just do the inner multiplication and solve it, you'll get the answer straight away. So in order to do the inner multiplication, let me do the second part alone first and then I'll just solve it, okay? So here you'll have negative u capital T and then plus u small t. So you'll have like minus half, plus half g capital T minus small t the whole square. So if I expand it, I'll have capital T square plus small t square minus 2 capital T small t, okay? Now let me do the one more inner multiplication. I'll end up getting all those constant. Then I'll be able to solve it, right? So if I just do the inner multiplication, ut minus half g t square minus ut plus small ut plus half g capital T square plus half g small t square minus 2 will get cancelled and then you'll be left with g capital T small t, right? Let me solve it. You'll have capital ut negative ut will get cancelled out, then you have minus half gt square and then plus half gt square will get cancelled out. Now let's write down all the parameters that is left after cancelling it out. You will have u small t plus half g t square, right? And then you'll have negative g capital T small t, right? So this is what is left. Let me verify it with the options over there. So when I consider the options, you have like u in that option and then t. So you do not have any capital T here, right? But in the thing that I found, you just have this one more capital T that is left, right? So I'll have to solve this one to match it with the options. To match this capital T, the only thing that is left is the first kinematic equation, right? V equals u plus at, because in that situation I'll be able to substitute g and the time is a parameter that comes into picture. So if I do the rearrangement stuff, I'll be able to put capital T in terms of some other relation, right? So let me use the first kinematic equation. Therefore the first kinematic equation here is V equals u plus at. If I substitute that one over here for the complete SN, the final velocity will be like 0, the initial velocity is like u, and then you will have like negative g minus g and then the capital T, right? So if I do the rearrangement stuff, we'll have like t which is equal to u divided by g, right? So to get this relation between t and then the u, if I need to relate between t and then u, only equation that is left is like the first kinematic equation. Therefore I did use that one. So here I'll just rearrange this t in terms of u by g, okay? So this t will be replaced with u divided by g, fine. So if I replace it with u by g, g will get cancelled and the leftover term will be like minus ut, right? So that will be left. So obviously this seems pretty clear. The only term that is left here is like minus ut and then you have like plus ut. Therefore these two things will get cancelled out. The term that will be left is like half gt square, right? So in the last t seconds, the distance covered by that ball or object was like equal to half gt square, right? In the last t second. If it was like first t seconds, then the straight away formula we could use it, which is like ut plus half at square. But in this situation, what they're asking us to find is like the last t seconds, right? Therefore, the answer here is plus half gt square, which is like option 2, right? So this sum is a little bit tricky. What they're asking us to find is the distance covered by the ball in the last t seconds. That's what they're asking us to find, right? Okay, so you should be clear with these kind of sums, right? If they're asking you questions that are related to this pattern, then you should know how to solve it. Fine, you should be clear with this sum. Let's move to the next one. Next sum is based on relative motion. Let's see what the sum is. Preeti reached the metro station and found that the escalator was not working, right? So she has reached the metro station and the escalator isn't working. That's the first case. She walked up the stationary escalator in time t1, right? So she is walking up, the escalator is stationary, which means the normal staircase she is walking up, right? So that's the first condition. On the other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2, right? So in the first case, the escalator isn't working, therefore it is stationary. She is walking on her own. In that situation, the time was like t1, fine. In the second case, the escalator is working and she is not walking up, right? She is moving with the velocity of the escalator itself. Then what they're asking us to find is the time taken by her to walk up on the moving escalator. So the thing that I'm supposed to find is, if she is also walking on the escalator and the escalator is also moving upwards, then what should be the time? That's what I'm supposed to find here, right? In the first case, only she was walking up, right? Escalator wasn't working, right? So that should be like velocity v1. Let's make it this way. In the second situation, she is like standing on the escalator. Only thing is escalator is moving upwards, fine. So in the third case, which is something that I need to find, both are actually working together, which means she is also walking up and then escalator is also working, right? So here what should actually happen? The velocity should get added, right? Let's make it this way. She is walking up with a velocity of 2 meter per second, fine. In the second case, like the escalator is moving upwards with a velocity of like 3 meter per second, right? If both those things get added, escalator is also moving up, she is also putting her effort, right? So in this situation, obviously velocity should get added, right? So that's the hint which you should know. From that, we will obviously be able to get the time, right? So let's find out the time. So time should actually be less than these two times, right? So it should be clear, because in the third case, both are working, therefore the velocity should sum up. If the velocity gets added, then the time should go down, right? So anyway, they haven't given you the numbers here, so we'll have to find a relation. How does the time relate with respect to those two individual times, t1 and t2, right? The hint here is the final velocity v will be like sum of those two velocity, which is like v1 and then the v2, right? Fine. So to get this thing, for velocity or speed, whatever it is, I'll be able to substitute distance divided by the time, right? So for the first, in all those three conditions, distance is just the same. Only thing is time is the parameter that is changing, right? So if two things work together, obviously the velocity gets added. For that, I'll have to find the time. So for velocity, I'll be able to substitute displacement or distance divided by the time, which is equal to v1 plus v2. In the first case, velocity was same distance, time was equal to t1, right? So that's the first condition. And in the second condition, she is like stationary and the escalator is moving upward. In that situation, time was like equal to t2, right? d divided by t2. So here, if both were working together, which means he is also moving up and the escalator is also working, these two velocities obviously get added. Therefore, I just put it in addition, right? Now, if I just solve it, the left hand side will give me t, which is the time taken by it, by her when both were working together, right? So if I do the solving, let me cancel out d, right? So the d will get cancelled out. Just do the cross multiplication and flip it, will get the answer. The cross multiplication will be like t1 plus t2 divided by t1 t2, and then you'll have to reciprocal it, right? Therefore t will be equal to t1 t2 divided by t1 plus t2, right? The answer here is option 2. Got it? You should be able to understand this sum, right? So this is also a conceptual based new pattern sum, right? If they're asking you sums that are related to this pattern, you should be clear. You'll have to add the velocity so that I'll end up getting the time, right? No doubt should be there in this question. Let's move on to the next one. Next sum is, a bus is moving with a velocity of 10 meter per second on a straight road, right? So the velocity of the bus is like 10 meter per second. The next statement is, a scooterist wishes to overtake the bus in 100 seconds, which means there is a scooterist, there is a guy who is actually following the bus from the behind and he wishes to overtake the bus with a time of 100 seconds, right? If the bus is at a distance of 1 kilometer from the scooterist, so the distance between the bus and then the scooterist is actually equal to 1 kilometer. With what speed should the scooterist chase the bus, right? So what should be the speed with which if he chases, he will be able to overtake the bus in 100 seconds. That's what I'm supposed to find here. The velocity of the bus is equal to 10 meter per second. Then obviously the velocity of the scooterist should be greater than 10 meter per second. So I'll have to find what the velocity is, right? So if you look into the options, it is pretty clear. All the answers are actually greater than 10 except option 3, which is like equal to 10, right? Fine. So let me draw a diagram for the question. So you have a bus which is traveling with an velocity of 10 meter per second. Okay, so that's the velocity, and that is a guy who is chasing the bus. Fine. So that is like a scooterist who is chasing the bus. The velocity of this scooter is something that I need to find, right? So velocity of the scooterist is something that I need to find. Velocity of the bus is like 10 meter per second. That the other data that they have given over here is the distance between the scooter and the bus at the time that I started is like 1000 meters, which is like 1 kilometer. All the options are in like meters, therefore I should use like meter convention. So here you have like 1000 meters, and the time that is there to cross this 1000 meter is like 100 seconds. So in 100 seconds he will have to cover an extra distance of 1000 meter, which is between the bus and then the scooter, right? So what should be the velocity of the scooters? That's what I need to find. So obviously the extra distance that he has to cover is like 1000 meters in 100 seconds, right? Therefore here the relative velocity between the scooter and the bus is actually given. What I'm supposed to find is velocity of the scooter is something that I need to find, right? So the relative velocity, extra velocity is like the relative velocity. In order to get that extra velocity, obviously I'll be able to divide 1000 divided by 100, right? So that will give me the relative velocity between the bus and then the scooterist. So if he is able to cover this extra 1000 meters with respect to the bus, then he will be able to overtake the bus, right? So here the thing that is given us like velocity of the scooter with respect to the bus is given, which is like 1000 divided by 100. What I'm supposed to find is velocity of the scooter, and here I'm just finding it with respect to the bus. Therefore I should consider the bus to be like stationary, right? So these are all the arguments that we have seen already in the theory part. You should be clear with the theory. All right, I'm just skipping off those things because I've seen we have discussed all those things clearly in the theory, right? Fine. So velocity of the scooter with respect to the bus will be equal to velocity of the scooter minus velocity of the bus. Fine. So here velocity of the scooter with respect to the bus will be 1000 divided by the 100 second, which will be equal to velocity of the scooter, which is something that I need to find, minus velocity of the bus, that will be like 10, right? So if I do the solving, zeros will get cancelled. Therefore velocity of the scooter will be equal to 20 meter per second, right? The answer here is like option 4, right? So you should be clear with these kind of sums, right? So this sum is based on the relative motion, right? No doubt should be there. Let's move to the next sum. Next sum is also based on relative motion. Simple one. Let's read it. A train of 150-meter length is going towards the north direction at a speed of 10 meter per second, right? So that is a train which is moving towards the north with the speed of 10 meter per second. So the velocity of the train will be like 10 meter per second. Got it? Then they have given you a parrot flies at the speed of 5 meter per second towards the south direction parallel to the railway track, which means there is a parrot which is moving the other way around, which means downwards. Fine. So you have a parrot, got it? So you have parrot something like this. So this is actually moving downwards with the speed of 5 meter per second, right? So this is equal to velocity of the parrot. Okay. So then direction parallel to the railway track, fine. The time taken by the parrot to cross the train. So here length of the train should be considered. Therefore L will be equal to 150 meter. Fine. Got it. So the train is moving actually upwards, which means in the positive direction, and the velocity of the parrot is downwards, which means in the negative direction. Obviously, this is like two men moving close to each other. Fine. So in this situation, we know from the theory that the velocity will get added up, right? So here the velocity will get added up, and what will be the time taken by the parrot to reach the other end of the train, right? So that's what I'm supposed to find here. The time taken by the parrot to cross the train is. So what is the time taken by the parrot to cover that 150-meter length? That's what they're asking us to find. Okay. So if I do the math, what you need to know here is velocity of the parrot with respect to the train, which will be equal to velocity of the parrot minus velocity of the train. Fine. So velocity of the parrot with respect to the train will give me the time taken by the parrot to cross the train, right? So as the parrot is moving south, the train is also in a favorable direction. Therefore, that too is covering some extra distance. Therefore, parrot will obviously be able to cross the train quickly, right? Therefore, here what I need to find is velocity of the parrot with respect to time train. From that I'll be able to get the time. Okay. So to get the velocity of the parrot with respect to the train, the distance of the train will be equal to 150 meters divided by the time, right? So which will give me what? Which will give me velocity of the parrot minus velocity of the train. Therefore, velocity of the parrot here is equal to like minus 5 meter per second, right? So you will get negative 5 meter per second, and for the train you will have like plus, right? Therefore it will be like negative of 10, right? So you will end up getting like minus 15 meter per second. So that will be the relative velocity here. So here obviously the parrot is moving downwards, right? So the length is getting covered in the negative direction. Therefore I'll have to put a negative sign over here, right? So even though you miss this negative sign, there wouldn't be any problem. Time will never be negative. Therefore it should actually come to positive, right? So just by looking at it, you'll get to know that I have made a mistake of not putting the negative sign, right? So you should be clear with this one. So if I do the cross multiplication, I'll get time t which is equal to 10 seconds, right? So 15, 150, both those things gets cancelled out. You'll have like t which is equal to 10 seconds, right? So the answer here is option 4, right? So these are like easy sums, fine. So this is like two person moving towards each other, right? So here the distance is like length of the train. Therefore, I just put it 150 meter. Okay, no doubt should be there in this question. Let's move to the next one. We are into the last part of this session. Now we will do sums from the year 21, 22 and 23, right? So let's see, 30th sum. The displacement time graph of two moving particles makes an angle 30 degree and 45 degree, right? So you got a particle and the graph is like 30 degree and then 45 degree. That's what they have given here. So here they have given us displacement time graph, fine, with x-axis as shown in the figure. Got it. The ratio of their respective velocity is, right? So I'll have to get the ratios of the velocities. So here first I'll have to consider 30 degree, then I'll have to consider 45 degree, right? So in that order I'll have to find the ratios. Okay, so what is the formula for the velocity? Velocity will be equal to del x divided by del t, right? So change in displacement divided by change time interval. Got it? So if I have to match this one with the graph over here, del x is actually along the y-axis. Therefore, this is like del x, and along the x-axis you have like del t, right? What they have given here is like the angle, right? So in order to relate angle and then the sides, obviously I'll have to use like sine, cosine and then tangent theta, right? We will do these kind of relation in the upcoming chapter. As if now it seems to be like new, but anyway you'll get used to these kind of ideas, right? Here if I consider the opposite side, that will be like del x, right? So this will be my del x and the del t will be like my x-axis, right? So here I'll have to relate between the opposite side and then the adjacent side. So here if I have to relate between opposite and then the adjacent, then obviously I'll have to use like tangent theta, right? So tangent theta will give me the velocity. Therefore del x by del t will be equal to tangent theta. Got it? Now I have got the velocity which is like del x divided by del t, which is nothing but tangent theta for this particular displacement time graph, right? So if I have to substitute like thetas here, I'll get the velocity ratios, right? So the theta that I'll consider first is like 30 degree, then will be like 45 degree, fine. So tangent 30 degree will be equal to 1 divided by root 3, right? So in the lower grades, you should have studied this one, sine, tangent and the cosine thetas. But anyway, we will do all those things in the next chapter. As if now you need to know tangent 30 degrees like 1 by root 3 and then tangent 45 degree will be like 1, right? So now I have got the ratios for like v1 divided by v2. So the answer here is like 1 is to root 3, which is option 1, fine. So you should be clear with this kind of sums, right? So here what I've done is I just considered the opposite and then the adjacent side. So I'll have to pick the angles, right? So here I could use like 3 angles, which is like sine, cosine and then the tangent theta. Here I do not have hypotenuse to be considered. Therefore, I just chose tangent theta here, right? So that gives me velocity for this particular displacement time graph, right? You shouldn't have doubt in this question. Let's move to the next one. Next sum is also a simple one. Let's see. The ratio of the distances traveled by a freely falling body in the first, second, third and then the fourth second, right? So distance traveled in the nth second, that's what they're asking us to find, that in ratios. So the formula will be like Sn will be U minus half G to N minus 1. This is the formula that I use, right? From the theory we have known this one. So U minus half G to N minus 1. What they're asking us to find is like first, second, third and fourth second. That too, it is a freely falling body, which means initial velocity U will be equal to 0, right? Therefore, I do not want to consider this term. Let's consider rest all other terms. You will have like S1 which is equal to negative half g 2n minus 1, right? For n I'll substitute like 1, so I'll have like 2 minus 1 in the first case. And then let's see for the second one, S2 will have minus half g 2n minus 1, right? So here it will be like 2, which will be like 4 minus 1, so that will be for my S2. And then for S3 you will have negative half g, and then you'll have like 6 minus 1, which is like 5. Fine, so 6 minus 1, let's put it that way itself. So you'll have like 6 minus 1. If I do the cancelling stuff, minus half g minus half g minus half g will get cancelled out. Then I could take the ratios. The ratios will be like 1 is to 3 is to 5, right? That's how the ratio should be there. So let's verify with the options. 1 is to 3 is to 5, and the next one will be like 7. Therefore, the answer here is option 4, right? So these are like simple sums. You shouldn't have doubt. Let's move on to the next one. This is the last sum for this session. This sum is based on the average speed. Let's see. A vehicle travels half the distance with the speed v and the remaining distance with the speed 2v. Fine. So the first half of the distance was traveled with the speed of v and the next half distance was traveled with the speed of 2v. I should find the average speed in this situation. Okay. So you have a vehicle that is traveling a distance d by 2 with the speed v. Okay. Then the rest d by 2 will be covered with the speed of 2v. Got it? I need to find the average speed in this situation. So the average speed means I'll have to put like total distance divided by the total time taken, right? So first I'll have to consider the individual time taken. So these are like simple sums, right? In the first session itself we have discussed these kind of sums. Therefore I'm just going it quick. In the first, I'll have to consider the first situation and I'll find the t1, and I'll put the second, I'll consider the second situation where I'll get the term t2. Time should be like same, right? Therefore t should be equal to t1 plus t2. That's the logic we are about to use here. So for the first case, velocity will be equal to d by 2 divided by t1, right? Then for the second case, you'll have like 2v, which is equal to d by 2 divided by t2. Got it? That this the time should get added, right? Therefore t will be equal to t1 plus t2, right? Fine. So now I'll be able to get the average velocity. Fine. So here, so instead of this one, instead of t, I'll substitute d divided by v, right? The distance will be like d divided by v average. This is what I need to find, which is equal to t1. Okay. So t1 will be like d divided by 2v for the first case, and for the second case t2 you will have like d divided by 4v. Got it? So the same variable will get cancelled out. You will have, so d will get cancelled out. Then let me factor out v. So you'll get 1 by v, which will be like 1 by 2 plus 1 by 4, right? So if I do the cross multiplication, you'll have like 6 divided by 8, right? So that will be 1 by v into 6 by 8, right? So if I just flip it, I'll get the v average, right? V average will be equal to 8 by 6v, right? If I cancel it out, I'll get like 4 by 3v, right? Yes. The answer here is option 3. Fine. So you should be clear with this sum, right? You shouldn't have any doubt in it. The things that we seen in the session were related to kinematic equation. We did solve sums that are related to kinematic equation. Then we did solve sums that were related to relative motion, right? Fine. So in this chapter, mainly you get sums based on graphical thing. Then you get sums that are related to kinematic equation. Then you get sums based on like that velocity, displacement and all those things, right? So these are the sums that you need to be clear in this particular chapter, right? So with this, the video gets completed. Bye.